So we're looking at linear equation. So linear equation is just an system of equation that you can use in real life to see the progress of your financial status in your businesses, to see if it actually makes sense or there's going to be any profit over a certain period of time. Linear equation is so important in mathematics that it actually can predict your future, and not so only future, but your whole growth of your whatever business or any one of those kind of uh, initiatives that you might want to come up with. Now, linear equation is also, well, when you look at linear equation, the highest degree in a linear equation is a 1. And what we mean by degree, we mean by the exponent of this equation. So when you look at the well, so if we look at the terms, well, this is just a coefficient and it's variable which carries the exponent 1. So that is the highest degree in, or the highest exponent in a linear equation is a 1. These terms now, these are referred to as constants, and these are real numbers. They can be represented by real numbers. It could be 1, 2, 3, 4, 5, 6, -1, -2, any of those representation. And so the objective in this linear equation is to find the value of x, find the value of the unknown. The unknown could actually be any other letter. It doesn't have to be x. It could be any other letter. So just look an example as an example. If I have x plus 2 is equal to, say, 4. Or to find the value of x, we must bear in mind the opposite operation. So when you're transposing an equation, remember we always remember the opposite operations. For example, the opposite operation of plus is take away, the opposite operation of multiplication is division, square root is square, and so on. So if we are getting rid of this 2, to have x by itself, we must apply the opposite term of 2, which is -2. So we subtract both sides, that gives us 0, and so x is equal to x plus 0 gives us x, and 2 from 4 gives us 2. And we could even actually plug this into the equation to see if what is on the left hand side is actually equal to what is on the right hand side. So if x is 2, x2 plus 2 gives us 4, and so that will be indeed correct. What if we had 2x is equal to 4? Now this is asking us, what number do I multiply by 2 to get 4? Well, intuitively we know that it's 2, but how do we prove that it is 2? Well, since the 2 and the x, they are multiplying, then we'll actually use the opposite operation of multiplication, which is division. So we divide both sides by 2 to get rid of that 2, so that this will give us 1. 2 divided by 2 gives us 1. 1 times x gives us back x, and 2 into 4 goes 2 times. And without any doubt, we don't have to evaluate this, because intuitively we said it, that it would have been 2. Let's look at another one. What if I had x divided by 2 is equal to 8? This is asking, now, what number do I divide by 2 to get 8? Well, we could say 16, but how do we prove it? We could actually do this 2 ways. We could actually create a fraction on this side and do what we call a cross multiplication and say x times 1 is equal to 2 times 8. And there we go. X times 1 gives us x, and we say 2 times 8 gives us 16. Another way we could look at it, we could actually, since x is being divided by the 2, we could actually multiply both sides by 2, because the opposite of multiplication is division. And so you're actually seeing the 16 on the other side. So this cancels that, leaves us with x all by itself, and 2 times 8 gives us 16. You could actually prove it to see if that is true. Another one that we want to look at, what if we had x plus 1 divided by, let's say 7 is equal to, let's say 7 is equal to 9. Or better yet, let us use a different number. Let us use some smaller numbers. So this is asking, what number do I add with x and divide it by 2 gives us 9? Well, we could do this many ways. We could actually create a fraction over here and do a cross multiplication as well. And then we'll say, actually say 1 times x plus 1 is equal to 2 times 9. And so we actually distribute this one with by each term to each term in the fraction in the bracket by multiplication. So we'll actually get back the same thing. 1 times x gives us x, and 1 times 1 gives us 1. 2 times 9 gives us 18, and so we'll actually make y this x is subject by subtracting both side by 1, canceling that, and so x will be equal to 17. We could even prove if x is actually 17. If x is 17, then we'll say 17 plus 1 over 2, should it actually equal to 9? Let's put a question mark there. Should it actually equal to 9? Is it true? Equal to 9. Let us see. If we add 17 and 8 and 17 and 1, we get 18, and we divide 18 by 2, we get 9. So it is indeed correct. So there you go. Finding the value of the x in the linear equation. You use the opposite operation of each term, so it doesn't matter what the equation looks like. That's what we always do.